Assalamu alaikum warahmatullahi wabarakatuh. My name is Ali Shahrani. Today I will talk about our project, which is steel bridge. First of all, bridge is a structure which is connect between 2 points over obstacle, such as body of water, valley, or highway. Some types of bridge: arc bridge, which is used for high level of strength and resistance, but it is cost a lot of money and take long time. Beam bridge, it has benefit of simplicity and quick construction, but it is affected by time and start to sag as age. Warren truss, we choose Warren truss because it's common used and it has the ability to spread the load evenly across a number of different members. Location: our project is location between King Fahd Specialty Hospital and malls and also activities area. Dimensions of our bridge is height 23 feet, length is 131 feet, breadth is 13 feet, finally slab thickness is 5 inch.
Assalamu alaikum, my name is Saad Batwari. Today I'm gonna explain the calculation in our project. We will talk about the analysis and design in slab. So first of all, we will talk about the steps how we find the slab flows. First of all, we need to find the cross-section area by multiply the breadth by the thickness, and we got the 5.46 feet square. After that, we need to find the dead load by multiply the density of reinforced concrete by the cross-section area, and we got the 819 pound per feet. And then we need to find the live load, and the live load we got it from the Saudi code, and we convert it to be 105 per square foot. And the distribution, live load, we multiply the cross-section area by the dead load, and we got 573 pound per feet. And the ultimate load, we multiply the 1.2 by the dead load plus 1.6 by the live load. So the slab load, we should do multiply the ultimate load by the length. And here we put the length 6.55 and we redesign and take the full length. In the design of the beam, we select the type of the steel A36. So the beams in the edge, two beams only, and in the middle 9 beams. So now we need to find the ultimate load, and we find it to be 0.92 kilo per feet. So we assume it's simply supported. When we assume it, we took the formula W ultimate by L square over 8. When after that we will find the M ultimate, it's equal 19.73 kilo per feet. After that we need to find the ZX, so can we select our section. After we found the ZX, we take the W6 multiply 12 section from the data sheet. And in the beam 2 design, we calculate the load ultimate 1.85 kilo per feet. So we assume it also it's simply supported, and we took the formula W ultimate by L square over 8. And after we found the M ultimate, we need to find the selection of the ZX, so we can take the section. And after we calculate the ZX, it equal 14 by 69, and from the data sheet we found the economic section, it's the ZX, it's equal 14.9, and the select section we use is W6 multiply 20.
Assalamu alaikum warahmatullah. This is Salih bin Himam. After we calculate the load on the truss and each joint, we have to calculate the truss load on each member. We took the data and we input it into the software. Then we found the load in each member, as you can see here. After we found the load in each member, now we are going to calculate the compression design. As you can see, our truss is a symmetric truss. So in member 1 and member 19, they have the same design. So we take the length is equal to 13.1 feet, and the maximum load is equal to 29.41 K. And for the Fy, we take it as 63 KSI. For the critical load, we take it as 24 from the manual, which is 2/3 of the Fy. Then the required gross area is equal to the Pu over phi C F critical. We found it as 1.36. Then we go to the manual and we found the section is equal to 46 by 8.5, and the gross area is equal to 2.52. In our truss, the support is fixed in the both ends, thus the K is equal to 0.65. Then we found the KL over RM. For the N value, we calculated and found it to be 70.46, which is less than 200, which is okay. For the FE, we found it, we take the formula, which is pi squared times E over L Rm times N squared. We found it to be 57.65 KSI. Then from the datasheet, the FE should be more than 0.44 Fy. If it's more than 0.44 Fy, we use the equation 3.2 for the critical load. As you can see, the formula is 0.658 power 36 over 57.65 times 36. We found it 27.71. After that, we are checking the width and the thickness of ratio, which is BF over 2 TF, which is equal to 10.1, and it is more than 10.83, which is okay. Then we go to the manual and we choose the cross section W6 by 8.5. After that, for the connection, we designed the welding connection. We found the TF is equal to 0.195 inch for the cross section W6 by 8.5. For the minimum welded size, from the manual, the data sheet, we found it to be 1/8 inch, and the maximum welded size is equal to 0.195 inch. Then the throat value, which is equal to W times cosine 45, which is equal to 0.14 inch. Then the capacity of the weld, We found it to be 4.41 kips, and the rupture value is equal to 5.09 kips per inch. For the total length of the weld required, LW is equal to 29.41 over 4.41, which is equal to 6.66. That's all about the tension members, and thank you.
Assalamu alaikum, this is Badr Yami. I will talk about tension design, F3 and F18, which is equal 16.3. At the beginning, we have 16.3 and our length 13.1 feet. In the first step, calculate the gross area, 16.3 divided by 0.9 multiplied with 36, the steel yielded. And the second step, find the effective area, 16.3 divided by 0.75 multiplied with 58. And then we got our gross area and effective area. Then we can select our beam, and we selected W6 multiply x 8.5, and it's a cross section 2.52, which is bigger than our gross area. And then find the slenderness ratio, and we got it above it's okay يعني. And then Rabitude check, all of them are okay. And in the conclusion, to summarize our work of designing, we successfully designed the tension and compression member, as well as welded connections. For the wiring bridge, used the load and the resistance factor design method. And additionally, we want to thank Mr. Sayyid Khaliq for his help. And Assalamu alaikum wa rahmatullahi wa barakatuh.